upload any videos. I took a week off. So welcome back to this course on the Comptia Network Plus networking protocols. Now that you have a basic understanding of the OSI model and its related concepts, you can use these OSI concepts to understand how the major protocols work and how each of the protocols within each protocol stack maps to the OSI model, thus describing its function. In this section, you will learn about four major protocol stacks and how each one handles the concepts of addressing, routing, interoperability, and naming. These four protocol stacks are TCP, IPX, SPX, NetBEUI, AppleTalk. The Transmission Control Protocol Internet Protocol is the protocol of choice today. It, like other protocols, is used to allow two computers to communicate over a network. However, TCP is used not only on local area networks, but also over wide area networks and the Internet. Actually, TCP/IP is the only protocol in use on the Internet. Addressing. Addressing the network entities protocol called host in TCP/IP parlance that runs the TCP/IP is fairly straightforward in TCP/IP. Each host is given either manually or automatically a dotted decimal IP address in the format of xxx.xxx.xxx.xxx, where xxx is the number from 0 to 255. Because addressing is a network layer concept, the protocols that deal with addressing can be found at this layer. The Address Resolution Protocol (ARP) is responsible for resolving an IP address to the MAC address of the receiving host. The MAC address is a data link layer address hard-coded to each network card at the manufacturer. When a TCP/IP packet is sent, at some point a router will need to determine exactly which station the packets are intended for. On Ethernet networks, the router will use an ARP lookup and ARP broadcasts. Essentially, the router listens for periodic ARP broadcasts from all hosts and records in the information in its ARP cache, basically a table that says which IP address is associated with which MAC address. When a router receives packets and needs to send them to a particular station on one of its own segments, it examines the IP address of the destination, looks up the MAC address of the station using ARP, and forwards the packets via Ethernet to the intended destination. Routing. On TCP/IP networks, routing is a fairly involved process. In order to send a packet through an internetwork like the Internet, the router must have three pieces of information: the IP address of the sender, the IP address of the destination, and the IP address of the next router to which the packet should be sent. The first two are part of the IP datagram being sent, but the router must figure out the last item itself. The router uses information it receives from other routers about what IP addresses they can have on their local segments in order to build a logical map of the network called a routing table. Then the router can determine the best way to get the datagram to its destination and send on the information to the next router. Routers build routing tables using either RIP or OSPF. The difference between these two routing protocols, which operate at the network layer of the OSI model, is that RIP is a distance vector routing protocol and OSF is a link state routing protocol. The difference between them is pretty simple. Distance vector protocols like IRP are used by routers to gather information about the hosts. about the hosts connected to them and to build a table of the address and the segment they are on called a routing table. The router then broadcasts this information to all the routers it is connected to. All of the routers then receive this information, add the route information to their own routing tables and rebroadcast them. Approximately every 30 seconds, distance vector routing protocol routers will rebroadcast their entire routing table. Eventually, all routers in the internetwork know about all the other routers and the network they serve. Link state routing protocol like OSPF works slightly different, whereas RIP routers will broadcast their entire routing table every 60 seconds. A link state router will send out to its neighbors only changes to its routing table. Additionally, link state routers have a more directed relationship with their neighbors. Instead of broadcasting all of its information to everyone on the network, link state protocols like OSPF prefer to send only updates and small amount of information to a specific list of addresses. Interoperability. Of all the protocols listed in this chapter, no protocol is more flexible, more interoperable than TCP/IP. As the internet gained popularity, everyone wanted to get on the net. As such, almost every computer have had to have two things: a web browser and some form of TCP/IP connection. Therefore, every computer that is connected to the internet is running TCP/IP in one way or another. Many companies have used the TCP/IP protocol suite to communicate with one another over the internet. Additionally, because of this phenomenon, every operating system has some form of TCP/IP protocol stack and as such can communicate with other operating systems on some fundamental level. Naming. TCP/IP hosts are named according to the DNS convention. DNS is a service that resolves names to IP addresses so that we can use friendly names like www.trainsolutions.com to refer to computers instead of the unfriendly IP address like 192.168.24.31. There are two parts to a DNS name: the host name e.g. www and the domain name trainsolutions.com. Each of these components is separated by a period. Typically, you would assign a host name that says where the computer functions, i.e. www. For a web server. The domain name, on the other hand, is usually the name of the company which the computer resides on, or some related name followed by .com, .edu, .net, or any other domain suffix. IPX SPX. When Novell Netware was introduced, it was designed to be a server platform for a local area and wide area networks. To that end, they designed a protocol stack that was very efficient over local area networks and that would also work on wide area networks. That protocol stack was the Inter-Network Packet Exchange Sequence Packet Exchange, or IPX SPX. Addressing. IPX is the network layer protocol that handles addressing and routing for the IPX SPX protocol stack. IPX addressing is actually very simple. It takes the 12-digit hexadecimal address as that is the address for the individual node on the network segment. The network segment is referred to by its own unique 8-digit hexadecimal address. For example, the address 0001 ABF3 colon 12A B341FF414 correspond to a station with a MAC address of 12AB31341FF414 on the network segment labeled 0001ABF3. Every network segment is assigned its own unique IPX network address. Since the network card has the MAC address burned in at a factory and for the most part can't be changed, it doesn't have to be configured. The only configuration that must be done is to assign the IPX network address and configure the server with that address. Routing. Most routers that route TCP/IP traffic can also route IPX traffic, although that they require additional software or configuration. IPX SPX is a routable protocol stack because of its routing protocols designed into it. The routing protocols for IPX SPX are RIP and NLSP IPX. RIP is very similar to the RIP protocol in the TCP/IP in that RIP for IPX is a distance vector routing protocol for IPX. Similarly, NSLP is the link state routing protocol for IPX SPX. Both work similarly to their TCP/IP counterparts. RIP uses broadcasts for the entire IPX routing table to keep all IPX routers updated, and just like OSPF, NLSP sends out only the changes to the routing tables and then only select the group of network addresses. So I'm going to leave it here today for this video. If you enjoyed listening, please consider like, sharing and subscribing, and thank you again.